Welcome to this video on the celestial blueprint, an exploration of the geometry and algebra behind conic sections. First named by Apollonius of Perga, conic sections describe the fundamental curves that govern both the motion of our cosmos and how we observe it, from planetary orbits to signal collection. At the origin of these curves is the double-napped cone. A generator line rotating around a fixed axis at a constant angle creates the universal structure for every conic section. By varying the angle of an intersecting plane, we can generate four distinct mathematical curves: the circle, the ellipse, the parabola, and the hyperbola. When the intersecting plane passes through the cone's vertex, the curves collapse into degenerate forms, resulting in a single point, a line, or a pair of intersecting lines. The circle is defined as the set of all points in a plane that are equidistant from a fixed center point, represented by its standard algebraic equation. A parabola is defined as the set of all points equidistant from a fixed line, known as the directrix, and a fixed point called the focus. Parabolas can open in four directions. The squared variable in its equation determines the axis of symmetry, while the sign dictates the direction of the opening. An ellipse represents the set of points, where the sum of the distances to two fixed foci remains constant, defining its shape and major and minor axes. Conversely, a hyperbola is the set of points where the difference of the distances to two fixed foci is constant, creating two mirrored curves. These shapes share a geometric relationship between the semi-axes and the distance to the focus, expressed through specific formulas that function as a mathematical engine. Eccentricity measures a curve's deviation from circularity. It is the ratio of the distance to the focus versus the distance to the vertex, defining the entire spectrum of conics. This matrix summarizes the universal specifications for each conic section, including their eccentricity, standard equations, and focal properties. As Bertrand Russell once noted, let the relation of knowledge to real life be visible, and understand how such knowledge can transform the world.